Today's content is brought to you by our partner sponsor, PPC, a Belden brand. Check out their wide array of products at ppc-online.com. We do have a great suite of tools in our industry that can indicate when there's a problem. And when we consider the amount of the different symptoms that we have, visibility and availability to, we can start to build a picture along with some other software like your PMA, profile management applications, to say, when do we need to go actually, fix this? And then once we establish that priority, that's when the technicians will, obviously drive to the location and pull up their tools and say, okay, this is the problem. This is the event. These are the symptoms that are displayed. Now, how do I determine, which device I need to go interact with to repair this problem? So I wanted to get into the optical link optimization pillar because I think this also translates over into the active device pillar too. We talked a lot in the old days of analog optics about NPR curves, that noise power ratio.
Right.
But that conversation is starting to lean into the amplifiers too, because they also have an NPR curve, and in some cases an MER curve that's very important. But one of the things that I didn't really understand as a young tech was that the analog optical link was the single limiting factor in the signal quality of any node. And that if your optical link wasn't optimized properly, then your signal quality in the node, either in the upstream or the downstream, would never be better than, whatever the NPR figure of the optics were. And so, we've spent a lot of time early on when we had these really large nodes with a lot less data, that we had to manage for noise because there were so many devices connected in a single upstream analog optical path that we wanted to avoid the laser clipping, because we didn't want to, take all of that funneled and combined noise and clip the laser. So we tended to optimize our nodes on the lower end of the NPR curve to avoid clipping, to give ourselves a little bit more headroom. But what we also did was limited the potential signal quality of that link.
It's a more noisy link now. You're getting into more CNR.
That's right. So It's a little bit more robust in the presence of noise, but the link itself is noisier.
Right.
And then as the service groups got smaller, we segmented node from 1x4s to 2x2s to 4x4s. The service groups got smaller. We added more upstream channels, but we left our optical links kind of in the dirt.
Yeah, and you weren't really adding any more noise, any more signal power to it, so you had plenty of headroom then.
That's right. So we've learned a lot now in more modern networks with these Ethernet optical links. That link optimization discussion changes, but the noise power discussion now kind of shifts over into the amplifiers, because as we're extending the spectrum,
we're adding a lot more signals, a lot more power to the amplifiers.